Hello, mentors. Welcome to meeting 6, separation. That's November 9th. And so this meeting is a little different because part 1 will be actually led by the classroom leaders. And so it's called move or not to move. And then the second part, simulation, that's going to be normal. So you will lead as a mentor as usual. So let's dig into some of the details. So this meeting will explore the topic of segregation in society, and there's several, approaches to this. And our approach will be using games and simulations, so students will understand how very small individual choices that look very inoffensive can quickly add up. Everybody's doing it, right? And have a critical impact on global systems. In this case, it will be causing segregation. So, you'll have a lot of separation, even if you started with a pretty healthy or mixed or diverse population or neighborhood. So this would lead to racism, other forms of discrimination. Now, very, very important comment, these activities are adapted from the parable of the polygons. And here's this link in the teaching manual, encase.me/polygons. And we really recommend use a very, very fun website, very interactive, in which you actually understand by doing everything that's going on. And so you'll be in good shape if you do this activity, play this game on your own before even reading the manual. You could also share it with friends and many things like that. It's really interesting simulation. And we've turned this online simulation into actually a meeting, right? An in-person meeting, physical, where you will be playing these type of games. But let's just return to our meeting. So the first part, move or not move, it's 25 minutes approximately, so it's not that long, and it will be led, as we said, by classroom leaders. Students and new mentors will participate in two activities. One will be about forming a human line, so a real line of humans in which that they make choices, avoiding being sandwiched by shapes that are different. And the other is about a human square grid in 2 dimensions. Will be followed up in part 2 simulations. So you will repeat this square grid simulation now on a board, and then you'll explore different aspects of the situation more in depth. For time management, you have 45 minutes for this part, approximately. And the second part has lots of simulations and things to explore. So it's not so much as this problem, then these other problems, solve, close solution, etc. But more like questions, deep questions, and open that you have to play the game again and make some tweaks in order to investigate it, in order to make conjectures. So it's a lot of back and forth. Now, what would happen if we did this or that? So be strategic about how to involve students in choosing. It's important, but also know how many of these simulations you can realistically do. Let me show you quickly, then we can return. We have 1, 2, 3, 4, 5, 6 at least simulations. So it would be unrealistic to do all of them one by one, but they may overlap in spirit, right? So maybe you do this simulation, you don't need to do these others so much, or maybe do it a little quicker, etc. So be very strategic. Students can also create their own simulation. So that's for time management. And let's look at part 1. So again, before you could watch this video that explains the scenario, the situation, and also before you can browse this website that we just discussed. So separation will be led by your classroom leaders. All mentors and students will participate in moving in a human line, and then they'll move in a grid. So let's not dig into many details. You could read these, of course, and coaching, you guys will be able to participate to see how it looks like. And I think as a mentor in this activity, the most important thing is to be kind of helping your students you're participating with, but also be very engaged and just very curious about the activity, very participant. So that's gonna be 25 minutes or so. And this is the second part of this activity. You form actually with humans an 8x8 grid. Some people are going to be triangles, some others will be squares, and they will request to move here. The rule is, okay, if 33% or more of my neighbors are my shape, are the same as me, I am okay and I won't move. Otherwise, if less than right like 33%, then I will request to move and I'll just move randomly to another place. So this is a dynamic activity. This first stage will just turn into many different stages, and then it will end, it will stop until everyone's happy, which is good. But then it's about reflecting what happened. We'll have a fraction bar also, these fraction bars that are going to be handy to visually compute these fractions, right? Because you could have if 0 neighbors, or you could have as many as 8 neighbors. And so when you're looking what's the percentage of the, for example, this triangle, it has 5 neighbors and 2 are triangles. So you could here look at fifths, which is 20%. So that's easy. And you would see that you got 40%, right, of your neighbors being on your own shape, right? The same shape. So these would be happy because 33 or more are my shape. So this particular triangle would not move, right? Whereas this may move because it has many more shapes that are not the same, right? But then the fraction changes because now we have 6. So we have to think in this street and make sense of these percentages. So this is going to be a very visual aid, and it's also a very cool thing about this meeting that it allows students to familiarize with these benchmark fractions, thirds, fourths, fifths, until I guess eighths here, these unit fractions, and then iteration of those, right? So for example, this would be 4 sevenths, and then you would say, okay, what's 14 times 4? And kind of do the math there. So that's part 1. And then after part 1, which was held, with all the people, right? Just one whole group. You end here in part 2, simulations, which is 45 minutes long. So here's the breakdown. You will first play together the game that we were just discussing in the 2-dimensional grid. Then you'll do some explorations for about 20 minutes. And as we say, you don't have to do or can't really do all of them. And finally, you'll make sure what you do at the end, hopefully, one of these explorations, which is called Game Changer. So this is one of the exploration. Make sure that students explore it, even if they did not choose to, because it would be a very powerful ending to the meeting. And so here's the logistics. You create this grid. It's just one for all the students. You have some chips of 2 colors. So you don't have to do triangles and square anymore, but you can just transfer it to 2 types of groups, and you'll start with a mixed condition. There's no much segregation here, right? So you don't have blocks of colors that are separated, and you will decide some intolerance with your students and just simulate taking turns. It's just like a collective game, but it's not really a game, it's more a simulation. You're just following rules. So you're not making choices in the game, you're making them outside of the game when you do the explorations, and then you see what happens. So here's some questions that can help. And the explorations, let's look at them in the student workbook. So after you play, you have lots of interesting things that you can do. So let's read some of them. So what if we play a non-symmetric game where one group is less tolerant than the other? More company. What if we add a third shape? Lower the intolerance. If we lower the intolerance and restart the game, what happens? Can we just have a paradise so nothing happens? So place the shape in a way that everyone's happy. Keep playing with more tolerance. What happens? And this, which we describe, is the most important. closing the exploration and the meeting, which is okay. What do we do? It's not all these explorations seem to, point that nothing's working towards lowering the segregation. This system just makes us get there, even if we try to tweak it. So how can we change the rules of the game? And that means changing the mentality of individuals or making incentives. So you could discuss about real world, of course, that allow us to move from a board with lots of separation to a board where shapes are more mixed, right? So revert this segregation. It's not going to happen naturally. And that's very interesting. Here, of course, some solutions, but I think the most important is that you really get familiar with the system and the game. That way you can help the students on the spot and, really be ready. And some quick teaching tips: less is more, as we said. Don't do all the challenges. Have students choose if possible, not just randomly, but like I really want to see, for example, like students could say, what happens if we have three shapes? And then I predict this or that. Ask for predictions at first. So students, you shouldn't just do the simulation and then just wonder what happened, but before we simulate, are you gonna bet that something's gonna happen? Why or why not? And here in the manual we say why this is important. Connect to real life scenarios, have kids state conjectures before and after simulations and help polish them. And here in the manual, we have a simulation of a student interaction in which they get increasingly more clarity in the sense of these statements, these mathematical statements about the game. They may be ambiguous at first, but little by little, they can collaborate and turn it into something that's more well defined, that can be tested out, and if it's incorrect they can correct it after, or make some cases. So all sorts of logical thinking there. And speaking about these terms in really about segregation, so this question is really important, but of course you have to do it in a very strategic way. Some students, I mean, you're not just defining terms, but you want to familiarize or maybe bring some experiences from students. But at some point, I think it's important, or it's worth that you bring these terms because, well, they exist for a reason. So you may start with familiar terms or with friendly stories, etc. But at some point, it's okay to really talk about discrimination, segregation, gentrification, racism, homophobia, ableism, and anti-Semitism, just to mention a few of these umbrella of things that are really related to this meaning. And also, if this was reality, what would be different from the simple model that we explore? I think that's a really important reflection. Our models are useful, but they're limited. So in the sense that they're simple, they're going to be useful. Otherwise, it would be just unmanageable. But they may also have some bias and some things that, reality may not just work as simple as in this model. So the model is just to engage reflection at first, but it's not reality. So still very, very useful. So we really hope you enjoyed this meeting. And again, it's going to be a little different because first you'll just be a student and play with the other students, and then you'll be a mentor for the second part of the meeting. Okay, so enjoy the meeting. Goodbye.